track, control, or measure the position of your pulsed CW or quasi-CW laser beam, there is only one product on the market that can do that: QUAD-4Track. Our new laser position monitor takes advantage of the superior performance of our pyroelectric quadrant detectors over silicon quad and lateral effect photodiodes. They are fast, handle high peak power without saturation, and respond to lasers across the spectrum from ultraviolet to far infrared. The QUAD-4Track is a powerful 4-channel microprocessor-based instrument that includes a full-speed USB interface and versatile LabVIEW software. It not only measures beam position, but also the power or energy of your laser. It is used with our 9 or 20 mm square quad joule meter or radiometer probes. Let's take a look at the QUAD-4Track optical setup. We're measuring the beam position of a pulsed Q-switched YELF laser running at about 100 pps and with pulse energy of about 97 microjoules. This is our 9 mm quad joule meter probe set up on an XY stage. It's connected to our 4-track instrument. The USB output is connected to the computer running our 4-track software. The analog output is connected to an oscilloscope, which can be used to view all 4 channels simultaneously. Let's take a closer look at this handy feature. Watch as we adjust the stage to center the laser beam on the quad detector. Note that as the voltage output of the 4 channels become equal, the graphic cursor on the PC screen also heads to the center of the XY axis. This is a great tool when setting up the probe. It can also be used for quick alignment tasks. Now we'll take a closer look at 4-track operation and software. On the main software screen, you see a large XY graph to the right that displays and tracks the centroid of the laser beam. You can see the red plus that represents the center. We're operating in the calibrated mode, and the laser beam is currently at about minus 0.37 in the x-axis and plus 0.96 in the y-axis. Just below beam position, we can read the total pulse energy, which is the sum of energy of the 4 quad elements. To the right, there is a display of pulse frequency and also a trigger indicator. Next, we can see the instrument controls like range, trigger, and auto set. You can set the range from 20 microjoules to 20 millijoules. You can set the trigger from 2 to 20%. This brings us to the bottom of the screen, where there are a number of important software features that enhance the operation and use of the graphic XY display. The first is boundary, which provides a circular target on the screen. It can be turned on and off, and the diameter set in millimeters. We've set it at 50 micron. Next is average data, where you can set the number of pulses averaged from 2 to 1000. We're set at 40. Then comes show history, where we can set the buffer size and turn the green tracking line on or off. Set to 0 lets you set an electronic 0 once you're near a physical 0. It's quite handy for basic alignment applications. You can set the digital position resolution from 1 millimeter to 1 micron. You select from a pop-up menu. We have set it to the highest resolution. When you're trying to center the beam, you'll find the plot zoom very handy. Let's talk about position calibration. Quadrant detectors are inherently nonlinear as the beam moves farther from the center. So, we've developed a unique method for calibrating the quadrant detectors for round uniform laser beams. Let's take a look at the calibration screen and I'll walk you through calibration. It requires the quad probe be mounted on a micrometer-driven XY stage and that you find the physical center before starting. Here you see the table with 9 set positions. Using the stage, move the quad detector in the x-axis only to the minus 2 millimeter position and hit the OK button. The instrument will measure and record the X position. Next, move the detector to the minus 1.5 millimeter position and hit the OK again. The process continues until the detector has moved to all 9 spots. After the last measurement is made, the data is fit to a multi-order polynomial. Correction factors are determined and applied to the raw XY data. And almost magically, the quad probe can now measure position accurately. When we go back to the graphic display, we see that X position is now +2 millimeters and Y position near 0 as expected. If you've been looking for a way to measure the spatial stability, beam walk, or position of your high peak power pulsed or CW laser in the UV to far IR, you found it, QUAD-4Track. For more information on our quadrant pyro detectors and QUAD-4Track laser position monitor, please contact us at info@Gentec-EO.com or give us a call.